Class, we have seen that involute gear shape and how does it work, and how can we trace that involute gear with the help of that involute tooth profile, and how long the gear meshing will takes place. So like that only we have seen in this last video. Okay, so in this lecture we just make a comparison. What is the difference between involute and cycloidal? So involute represents there is a center distance for a pair of involute gears. It can be varied within limits. Okay, but whatever the case in cycloidal gears, it has been totally, it is a false information. It cannot be traced it like that way. Okay, and the pressure angle for the involute gear, which has been start from the engagement of teeth to the end of the engagement. Wherever in the case of cycloidal gears, it is maximum at the beginning of engagement, and it can reduces with respect to the pitch point, it is reduced to 0, and it's the value of the pressure angle which has been keep on decreasing. Pressure angle is nothing but it is a meshing of two gears where the pitch circle diameter which can intersect at one point. Okay, but the pressure angle which has been keep on decreasing, and again it becomes maximum at the end of engagement. Okay, in case of involute gears, we need to take there is a face and there is a flank of involute teeth which has been generated by a single curve, and here it is an easy to manufacture, but wherever if you take an application of the cycloidal gears, it is a double curve strand and it is an epicycloid, and there is a two different kind of cycloidal shapes are there. One is called epi and another one is an hypo, but here the manufacturing of cycloidal gears is not an easy task. It is little bit difficult. Okay, and this can be varied. Okay, so with respect to this point, this can be varied. One is an cycloidal gears and another one is an epicycloidal gears. Okay, and there is a change in the cycloidal gears with respect to the curves of engagement, and also when there is a smooth running takes place, the amount of engagement which has been keep on varying with respect to this pitch point, and the pressure angle also which keep on increasing. But in case of involute gears, that that shape has been reduced, but at the same time it can be varied with respect to this change of the pressure angle. Okay, so this pressure angle which has been mentioned in varying conditions. Okay, and this changes which has been varied with respect to the cycloidal gears. Okay, and this wider flanks which has been presented in terms of involute and as well as the interferences, and it occurs that there is no interferences and there is a less weight one, and therefore the wider flanks for the involute gears is 0, but whatever the case, this values has been varied. Let me coming to the standard proportions of this one. So generally for designing any gear, we used to follow this standard. One is called an particulars and another one is called an annotations. Okay, so if you take a case, there is a 14.5 degree of the composite. It is the full depth angle of the gears. Okay, and if you take a 20 degree full depth involute system, and if you take a 20 degree stub involute system, it is varied. So addendum which has been equally maintained for 14.5 is in 1 meter, and for 20 degrees in 1 meter, and for 20 degrees 0.5 meter. But in case of dedendum, the values has been decreased from 1.25 to 1 meter. And in case of working depth, it has been increased from 2 meter and again it comes to 1.60 meter. And when in case of minimum total depth, starting from 2.25 and ends with 1.80, and in case of tooth thickness, it's starting with 1.5708 meter, and it has been constantly maintaining the same value for the other different degrees. and minimum clearance is about 0.25, and fillet radius it has been maintained like 0.4 meter, and remaining we will continue on next session. Thanks so much.